Hi, Martin.
Hi, Martin.
Hello.
Kamil also should come today because he added himself.
Yeah. Yeah, he just messaged me about some tests that he was running, so he is online.
Let's see. Okay, I pinged him. So today, he's coming. Let's wait.
Hello. Oh, the cloud is back.
Hello. Yeah.
Yeah, unplugged though.
Well, it seems you do have a cloud connected printer, it seems.
Yeah, true. But also unplugged. So.
Well, maybe also the iron. We don't know where the cable goes. It's very important.
How are you guys?
Yeah, not too
Great.
bad.
I'm in Düsseldorf today. So back in my hometown.
Oh, really?
Yeah. But
He's
anyway,
It's never been closer to Amsterdam.
yeah, it's not so far.
Where is it?
So I'm originally from Cologne, but
yeah.
Düsseldorf is very close. So
Yeah, definitely. Yeah.
yeah, it's not so far from you guys.
No. Are you there for the
Okay.
summer or?
No,
just-
my son was at my mom's for the summer holidays, and I'm picking him up tomorrow. So today I'm in the hotel so I can work, and tomorrow I pick him up.
Yeah.
Awesome. Let's get the meeting started. And let me all remind you that by being here, we all agree to the GraphQL Spec Membership Agreement and to the GraphQL Foundation Code of Conduct. These are, as always, linked in the agenda, and if you need a refresher, you can have a look. So let's do a quick round of introductions for our future watchers in the order of the agenda. I'm Michael, and I'm today the host.
I'm Pascal, and I'm from Chili Queen.
Coming from the guild.
Martin from Apollo.
And Derek from Apollo.
Yeah, Derek, can you add a pull request? I don't know if you have, but just so we can...
I already did. Yep.
Awesome. I will
just a minute ago. So sorry.
Don't worry. Don't worry. Okay, today I have put a couple of agenda items in. The first is we're gonna review a bit the spec text around the directives, and then we can start talking about the composition, because that's the next big thing we should produce spec text around and structure around, and it's good to have a first discussion on that. And the directives, we're going to review a couple of times, and I think we have a good structure in there, and we will add details over time. So let's start with reviewing the, Derek? Yeah, hands up.
Just also one question. So I think the plan was to also bring it some of this working group status to the primary working
Yes.
group on the next week, right? On the
Yeah.
GraphQL stuff, right? The main primary working one, right?
Yes. Yeah, that's a good point. Because in August we'll take the first bits and pieces over to get a bit of feedback, mostly regarding syntax, because Lee has a lot of good input into how we should handle syntax, new syntax in GraphQL in general. So we're gonna get a little bit of feedback of the work, and then basically move on.
Yeah,
We will
on-
do that periodically. So update them. Let's say every 3 months or so. We take something significant, and then present there, and take the feedback back to our working group. Go ahead, Pascal.
Yeah, on that note, it would be great if you could have a look at the syntax spec for the path. I was a bit late. I said that I will publish it just after the working group, but then I was a few days gone. So anyway, it would be good if you could give feedback there. Then I will add this for the next week. Then we can have a quick look. And I believe then we should add 2 agenda items to the primary one. If there's still space, I haven't checked. Is it already busy agenda in?
No, we will have place. I already talked about that, and
Good.
we will get some space there.
Awesome, sounds good. So let's get going.
Okay, so this is the first working group in a long time that we don't start with the selection map syntax, so review it. But this is in a separate task. We're gonna merge that, and then if you find something, just comment now on the PR, and if there are future changes, we can always add more to it, right? But we're gonna merge it for the primary meeting, so people can have a nicer reading experience.
So let's say like the time to review it is by end of day tomorrow, like so end of this week, like working week, or
Yeah, you can review and put input, I would say, until next Wednesday.
so that's being generous. Okay, so trying to force people
Yeah,
to
don't worry if we find something, like it's nothing binding. It's just to get an initial feedback, and if we have thoughts or changes to that, we can always raise another pull request. Just basically.
We know how things are, right? So when you have the meeting, then and you have to write spec text, then usually you realize at Wednesday that it's already Wednesday, and then you write the spec text on Thursday. So it's common that when you do weekly meetings that we review stuff on the day that the meeting is. Don't worry.
And it might also that we get feedback from the main working group and then take that again up in our weekly meetings. Okay, so let's start actually with directives. So I composed a bit the spec text, and let's actually jump over that. Yeah, so this is like the directives we have so far. I've also started researching the Apollo directives a bit more, but we come to that at the end. So this, by the way, is also in the pull request. The pull request is, let me show you. We have that request. Yes, introduction of lookup directive. And that is all the text that we have there. I will clean it up. The temp file will go. That was a space holder. But there's all the text in this chapter. Okay. So the lookup directive, I've spec'd out most use cases that we have now. there's a simple use case where we have basically the arguments match really a field on the return type here. That's also stacked here. We have the basic use. We have outlined here that these IDs have to align with the keys on the entity types, and also that if we have an interface, then this interface also has to expose the key fields that are involved in this key, right? Also goes more into details about abstract type here a bit, and shows like a bit of an example how this would look with a union, for instance, and explains that if you have a union, each of the unions still has to follow the still has to have matching keys to the arguments that you specify here. Also introduces a bit of counterexamples, like this, for instance, would not work out because like category ID in this case would have no use and would not be valid. Yeah, I thought that you might.
Yeah, I'm wondering, because that sort of assumes a direct relationship between key and the arguments.
Yeah, yeah.
But I think it's definitely worth a warning. But I don't think semantically there's anything wrong with this, because what that lookup specifies is that
that you have both these, right?
Yeah, that the return object will have those values for those two keys.
Yeah, I found it could lead like very easily to bugs. That was my thinking around that.
I think I agree with that, but that seems to suggest a warning maybe more than like a strict.
Yeah,
but
we can definitely.
We should talk about that. Yeah.
Yeah.
Well, it would definitely simplify things, right? If we tie them to specifically to the lookup, so the keys and lookups are tied, it simplifies things, right?
Yeah.
If we don't tie it, it's more flexible. Definitely.
Yeah, it's more flexible. Could also lead to ambiguity, because you could have two of these lookups and one maybe just with the ID. I don't know. It could quickly lead to mess.
But there are cases that we want to support where there's no one-to-one relationship, I think, with like the nested lookups that we discussed before.
Yes, I'm coming to that. But I mean, this is all. Let's discuss all the details and add more examples and why this is good or why we want to have a warning there. This is just the initial.
One thing is here what we have to keep in mind, because I don't know about you, but I usually forget this when I read these specs. It's fine. The use case like this is perfectly valid and fine, because you already have clothing, so you have the key. So this lookup could match, but it could also match another lookup. So I'm not even sure if it should be a warning, because it would be completely fine. You would
but even if you imply but in this case you imply that category ID is needed.
Yeah, but even if the category ID is required, and it would be required on electronics, and clothing wouldn't even have a category ID, it would still be valid, because you already have the object, right? You already have a JSON that says you have a type name clothing and you have an ID, and you can infer from that this lookup will not match.
No, this could be an entry.
Sorry?
This could be an entry level lookup, right?
What do you mean entry level?
An entry level is, this is the first thing the user uses, like enters our graph in, and it's not said that this is just providing additional data, so you don't have an object for that.
But then it's not the entry level and the lookup are two separate concepts. They just overlap. It just happens to be when you expose a lookup as non-internal, it just happens to be there, and you can use it. It could be perfectly valid to say that it will never return clothing, right?
Yeah, I still find it very strange that this has no effect then. like, I mean,
Well, I mean, it does have an effect for electronics, right? You need it for electronics.
Yeah.
Um,
but it doesn't have an effect on closing. It could be fine, right? It's not necessarily something that functionally is an impediment. I just thought it's like introducing ambiguity to the graph.
yeah.
But
But
I'm totally fine.
it still has an effect, by the way. Like it does guarantee that category ID on the clothing object you get back is the same category ID you passed in. So
Yes.
theoretically, like query planning, for instance, could be optimized based on that. Like if you want to do a further like a sub fetch based on the category ID, you don't have to wait for the response from like you don't need the full clothing object in theory.
Yeah.
You could do things in parallel, for instance.
But would this only be, is this because of the semantic equivalence between the argument and the key or the field?
I would say the fields. I don't think the key figures in that at all.
Right. I see.
So a follow-up question then. So if
Yeah.
we have those arguments, right, to the lookup query, is there a requirement that all of the arguments are actual corresponding to some key or keys? Or is it possible
so-
non-key arguments there?
So this may also be something we want to change if we change the down thing. At the moment, I've written it the stable key is defined by the arguments of the field. Each argument must match a field on the return type of them. That's okay. But
yeah.
But there were some. It's coming further down that it has to respond to the key directives. And I think, we'll discover it as we go. Okay, so we can take this out. Let's discuss that condition. We can take it out. We could leave it in. We could also define this is a warning. While this is valid, probably we want a warning, or because it could also be a mistake, right? That you left this out. Because category ID maybe is here.
I think if anything, the warning here would be that like the union product, like there needs to be a shared key maybe.
Yeah.
But that's still like independent of the lookup.
Yeah, we can think about how we want to define that and where this has to sit.
Yeah.
Okay. This again, okay. So if the lookup is an interface, it has to expose here the key as well. Lookup fields. Yeah, look. That's a section I actually looked up, right? At the moment, we are describing here lookup fields must be accessible from the query type. If not directly on the query type, they must be accessible via fields that do not require arguments. That's the first thing. So you can have these namespacing fields if you want. But also, you can have nested lookups additionally. That means if a lookup is followed by a lookup, then this is also fine and will basically for the server become one lookup internally, right? Where you can look up the product price, for instance, directly by region name and the product ID. And this is also the keys defined, like we discussed, that in this case, product must be on the product price here, so we can reach the product ID.
Yeah.
I also have a counter example. Don't know, let me check. That was actually, I might not have it in the compiled version. Yeah, the counter example would be, and we can discuss also here how narrow we want to capture that you cannot have fields between the lookups. This is a must, or if this would have an argument. because this argument would be unbound. We would not understand what it is.
Yeah.
About this, we could discuss that it could have non-argument fields in between. But again,
I think that case is similar to
the
like
namespace.
starting from the query. Yeah.
Yeah. So I, at the moment, put this in as an argument. We could also reshape it and say like a non-argument fields are allowed, like with the namespacing. But
we could even be more strict about this, because in theory, there's nothing keeping a field with no argument from like still not returning a stable object. Like it could be a current time, or something. What we're actually saying is that certain fields return a singleton.
Yes.
And
Yes,
maybe we want to make that explicit.
But how do you want to mark singletons?
Well, with a singleton directive, if we really want to be fully explicit.
Yeah, but it also would add a lot more like brain complexity for people.
Yeah.
That's why I thought in the beginning, like that's why I was here more strict and that basically lookups have to follow lookups.
Well, but I'm talking about the namespacing case as well. Like I think we need to treat those two cases similarly. So either allow both, like no argument cases without any further annotations, or something like singleton as an explicit annotation.
Yeah, because that is actually also what this is, right? Because if this is not a singleton, it could be that it produces always new of these, and this could have side effects.
Yeah, although now that I think of it, what's weird about this is that it's not truly a singleton, right? It's nested within a particular product.
Yeah, but I know what you mean. This has to be stable in the sense of the combination of these, like product and this, is that it always produces the same of this object.
Yeah.
In the combination with the keys.
Yeah. And maybe the no argument is enough to signal that, because it's sort of what we assume for other fields, right? We assume that if we have two, like even if two subgraphs have the same price field as a shareable field, we sort of assume it's functionally stable.
Yes, because it's data essentially.
Yeah.
Yeah.
But it may be something to at least call out, or I don't know if that's needed, but
yeah, I'm gonna specify. Yeah, I'm gonna specify that a bit clearer, and also align the examples that we have the same here.
Yeah.
And here.
Now that I think of it, I think actually, and maybe this was during like Federation 2 design. I think at one point we actually discussed a volatile directive that would sort of signal the opposite.
Yeah.
I don't think we necessarily want to go in that direction, but it's sort of that's what it brought to mind. I think it's sort of addressing the same issue, but from the other direction. Making it opt out instead of opt in.
Yeah. Let's settle on something simple. I will add here. So this should not have argument. If it has if it's just data fields, I don't know. I will describe it more. Then it's okay.
Yeah.
But as soon as it has arguments in between, it's not allowed. And then we can think about where to take that. But this already, this already would allow to just integrate GitHub.
Yeah.
Right?
Yeah. It might even be worth to use that as an example, because it's so well known and it makes immediate sense.
Yes, I didn't do that because I wanted to be consistent in the schema domain that we use to not confuse people. Yeah, I will talk to Benji what he thinks about switching in a different example.
Yeah, I think if
Just
we wanted
for-
to stay within this domain, maybe like nesting a product within a store or something, or within
Yeah.
a region.
Yeah. I took this because the most federation examples actually use this product shopping example, and it's very easy to understand for people. Yeah, but yeah, ideally we stay in the same domain. Then the spec is very consistent in what the examples is, and yeah, we can definitely have a better one.
Yeah, I know how difficult it is to come up with examples.
Yeah, it's always you have a use case in mind, but not the domain for it. But
Yeah, the store and the product, that's kind of be like you have products underneath the store kind of thing or whatever.
yeah. Yeah, for this is what's easier. Like a price could be regional, so you
Yeah.
have kind of. But also, I constructed it. Okay. So the internal directive, I outlined here a bit what it is for. It's like removing things as entry fields. This is what it does, and also to remove technical lookups. Lookups that are only there as lookups, but that we don't want to expose on the public or the client-facing composite schema.
Yeah.
But that now is very clear that this is not the semantic of inaccessible, because like this is really bound to a lookup at the moment.
Do we need distinction of like calling out like the supergraph kind of thing, or that's like a different like naming? So this is available for like in the supergraph schema, but not available.
We call it the composite schema is what the
okay.
Yeah, so we have like three terms. It's client-facing composite schema, that is really the what we call the public API. Then you have the executable composite schema, which is the annotated, what we call subgraph. And you have source schema, what is subgraph schema. This is outlined in the introduction. Get the terms. So it's also linked to the naming of the GraphQL core spec. Like you can navigate from there directly what is the schema. There's no, like, we don't have any transport specifics in here that will all sit in the transport specification. So it's really about the GraphQL schema.
Yeah.
Okay, let's go on in the and okay, internal is I think good. So is directive, there we probably need more examples. I just introduced the basic ones. One thing I outlined more is that allows to map data, but also by introducing a map, introduces also semantic equivalence.
Yeah.
And
I think we may want to call out, I mean, it's part of the directive definition, but we may want to call out that we're using a specific syntax here and like link to the syntax.
That is shown here. We have the argument section, and once Pascal's part of merge, we're going to link it. Like you can click on that. What is the scale? Like here, we will put the scalar on the scalar name. At the moment, I think we have named the scalar already.
Yeah, but I think from an exposition point of view, maybe you actually want this in like one of these first paragraphs as well to sort of signal that this is it's not just a mapping to a field. We have syntax for mapping to like.
That's a good point. I will put I don't know if we put a note in between here that links directly to the whole chapter.
Maybe, yeah, I can see that working. Yeah.
And then people can just jump off and read all the spec, because it's a lot of text.
Yeah.
And inlining it in one of the directives would
No. I was thinking of like one or two sentences that basically specify that we like the mapping syntax allows for more complicated scenarios like nested fields.
Yeah. I mean, definitely we have to link that. But like we should also have a couple of these examples up here.
Yeah.
Like not all the complex examples with lists and stuff. I think that's good in the chapter, but like the basics. Like I did here, for instance, okay, you can basically grab a nested ID, or you have here, you can use like with combination with the one-off directive, you can basically use, there's a pipe missing, but you can basically distinguish between keys, basically use multiple keys. And depending on what key is available, you can fetch through that the person ID. I think this is a use case that many people will actually go for.
Once one-off is fully supported.
Yeah. And it's I think we're gonna raise it now to accept it in the next two working groups. We talked about it in the last working group, so it's coming through. Yeah, but this is like one of the use cases I can see, and this could be also like a technical requirement or whatever. Yeah, but there maybe 2 or 3 more examples and polish it a bit more, and then this should also work out. I can see here a couple of things missing, like there should also be lookup. So it's clear that it's only available with the lookup directive, or this like internal, this is only valid in the places where you have a lookup, at least for now.
Yeah.
Okay, the same goes for requires. So we have basic introduction of requires, how it works, that what it produces. Like if you have this on the source schema, you have this in the composite schema, so that people are clear. Basically, we remove all the required fields because they are basically technical data requirements that we have between source schemas. There's one thing I specified at the moment. Maybe this is also worth discussing, because I said that the data requirements are from other subgraphs or other source schema.
Yeah.
That means you cannot require data from the same source schema, which technically would work, but I think would lead to inefficiency. But this is also something we can discuss if that is a use case that is out there. I don't know if it would lead to inefficient patterns. That was why I excluded it.
I mean, from a distributed execution point of view, like I think all we could do was like first get the size and weight, and then call into the same subgraph again, which is indeed inefficient. Or likely to be inefficient. Yeah.
Yeah, and to be honest, I thought about, you have a context in GraphQL, a new GraphQL server, and there are much more efficient ways to actually do that within the GraphQL server to solve these kinds of problems.
Yeah.
So I excluded it, but if there is any use case for it, let's discuss it.
So should there be like a warning or error if there is a dimension object or like dimension field in a product that has a size and weight?
Not necessarily. Also, I always thought from a query planning perspective, but I don't know if we want to call that out as composition.
Because, well, we are saying that the data has to come from the other schema, right? Because that's what it's used for, right? That how you would.
Yeah, the way I thought about it is that dimension has to exist at least on another schema.
Mm-hmm.
Well, but also I think it can't exist in this schema.
That's what I'm saying. Like, so dimension maybe exists there, but size and weight wouldn't actually exist here.
Okay, that's another possibility. Yeah,
that's a good point. Yeah, you're right, because dimension could be a shared object,
Mhm.
but then size and weight need to come from somewhere else. I will add that at the note. Explain it a bit more. Okay. I also explained here a bit that you have requires with inputs. In this case, we map these objects. But again, like we can add 2 or 3 more examples here with the syntax. But then the rest you have to read up in the separate chapter.
Yeah.
Okay. Yeah. So this is where I am at the moment. These directives, you can see they are a little bit less. I'm at the moment looking at what Apollo Federation specifies, but you guys can also tell me where I'm wrong, what I'm producing here. But I'm basically doing a lift and shift. What is in the Apollo Federation documentation is basically what we gonna do with these directives. And I think I should have them finished. Maybe tomorrow.
Can you scroll up quickly?
Yeah.
Key fields are always considered shareable.
Yeah, that is also.
Isn't in a federation, as soon as a type has a key, it's an entity, and the entity is shareable, right? It's
Just
not
key fields.
No, not all the fields of the entity are shareable.
only
No.
okay. Only the
Only
key
key
fields
fields.
are automatically shareable. Okay, fair enough.
Yeah, I'm adding like this is. To be fair, I haven't invested a lot yet in it, but I'm gonna specify it through. Take basically behavior from the Apollo docs, and then you guys can give me more input in where I'm wrong. Everywhere, right? Everywhere we have concerns, just add comments.
Yeah, and I don't think it's just about being wrong. I think and we don't have to do that immediately, but we want to make sure that it's a good source of information for
Yes.
people, that it introduces them to the concepts, and there's like that's a documentation task, I think, that will be ongoing for a while.
Yeah. I know, and it's like there is no final version. We're gonna iterate on that.
Yeah.
And make it into good documentation. But this is basically where I just say, like, I'm gonna do a lift and shift there because like we discussed the functionality of these and basically agreed that we take them over.
So Michael, you've opened up also like the introduce key directive, PR.
Yeah.
Long time ago.
Yeah.
Should that be just merged together into the single one, or
Yes.
do separate?
I actually already did that locally. No, I didn't. I'm gonna do that because at one point I just went on the whole directives. I'm just integrating that all. Yeah, good point. Because the key directive is also basically a lift and shift. Like we use the selection set syntax. This is something we also have to specify out what the field set really is and how the syntax works.
Yeah.
And then we also have to basically the same work that we did for the syntax now have to do for that as well. So it's very explicit what can be there and what cannot. So we also have future evolution space, I would say.
Yeah.
Okay. So yeah, I will ping you guys tomorrow basically when I copied over the rest of the directives, and then you can have a walkthrough and do comments, and then we can take the first bits and pieces to the main working group, present there, basically give an initial overview of what the direction is.
I'm wondering, do we want to set the stage a little bit? Like, because like originally this working group was much broader. Like composite schemas is a pretty broad category. And what we've landed on is sort of more closely related to the notion of federation. We have our like design principles. Is that something that we should call out during that meeting, or
Yeah, it's basically, yeah, we will point to the heritage. Basically, that this is a more distilled version of federation. I think also a more compatible version with the rest of the GraphQL, because you don't need entity fields. This opens up for external schema integration and stuff like that. But yeah, we're gonna.
oh yeah, but I meant the other direction. So specifying that we're not like this is not meant to be like a general solution for composing schemas. What we're doing here is like solving a fairly specific use case of like distributed execution, like static composition.
Yes, we're gonna do that.
Yeah.
Let's talk separate from the meeting, Martin, and then we can present it together if you want.
Yeah. I just want to make sure we don't like either give the wrong impression or get like discussions that are too off like the path we were already on.
Yeah, and I think within the group we are all clear that we are not introducing new schema stitching or other approaches, that we have a very clear understanding of what we.
Yeah, we all did the same mistakes, so.
Yeah, let's I will prepare a couple of slides, and I will put them on Google Slides so we can work together on it if you want.
Sounds good. Yeah.
Okay, with that, we have another topic. I don't want to solve it, but I want to start discussing it, and this will, I think, take a while for us to start thinking about that. At the moment, maybe let me show how we structured the chapters a bit. There's not really something there yet, but we have at least a rough structure. So these are the basic blocks we discussed at some point. And sorry for the background noise. I have to share a lounge here.
Yeah.
So basically, we have the 3 pillars: validation, and that means the subgraph validation. Basically, we compare or validate each schema individually if they are. If we could start composition basically with that. Still, after this validation, it could fail in the compose step, which is bringing these things together. But this is an initial validation. Is the source schema valid, generally valid?
Well, but it's more than that, right? It adds additional validation rules beyond just normal GraphQL schema validation.
Yeah. But what I mean, like with the use of our directives.
Yeah, I'm wondering if we should call it subgraph validation, just to be absolutely clear.
Yes, we can definitely do that. Like add that here. I
think
I'm
at the moment, is this what is the okay? Do we have the algorithms in there already? The few ones that we drafted once.
The validation rules, yes, and we can go over them. Which one is good? Which one is not good? Some might even be.
Yeah, I think there's a few in there which is a bit of a mix between subgraph validation and global validation. So I think we should define the context. What we validate there. If we just run the graphical validation and then run the syntax validation for the path, because there's validation rules. And then we have some other validation rules probably, which are applicable just for subgraphs. But then the question is there, before we go into the compose step, also a validation step where we have the context of all subgraphs without merging them? Or
I would say that comes after, at least that's where it comes in our current implementation.
yeah, but is it a validation step or is this a compose step is the question, right?
Well, I mean, I think what we do is after subgraph validation, we compose, because that sort of ensures that we can actually get a composition result. we can get a composed schema, but after that we run additional validation rules on the supergraph schema, on the composed schema. And satisfiability is part of that, but it's like there are other rules that apply to the supergraph level as well, because
Right.
there are relationships between subgraphs. Basically, like if you have a require, the fields like need to be defined in the supergraph.
Right. So the merge step.
Yeah.
So you do a subgraph validation, then you kind of do the merging into the supergraph, the composition.
Yeah.
And then you do on top of this, you do the additional validation rules, including satisfiability.
Yeah.
Right.
Maybe compose is too much here. Maybe it's, well, it is composition, but it's more like merging maybe, or
I mean, we can also have this. The whole thing is the composition, right? We could have
exactly.
subgraph validation, then we could have merge, then we can have supergraph validation, and then we can have satisfiability.
Yeah.
I think
So merging and then
that does bring up the point. Like I still think subgraph and supergraph have sort of become like terms of art, and people know what we mean by them. But in this specification so far, we've been avoiding them.
Yes, we are using, yes. So we are using the terms that align with the graphical core spec.
I'm not sure
because we are working on schemas, whereas like subgraph is basically
it's a subgraph schema, and it's a supergraph schema.
Yeah, but in the graphical context and the specification context, we are not talking about graphs at all. Like it's always the schema is the type system, and we are basically merging the types. You know.
I think it's just like subgraph and supergraph. Like they describe the role.
Yeah, I know what you mean. Like where you guys inferred the terms from, right? But there's also like the supergraph that was originally GraphQL, like Facebook originally called GraphQL supergraph. There's a supergraph term that now Hasura is pushing, which is not aligning with that. It's like also an overlaid term. Supergraph IO, what is this? Oh, that is Hasura's new.
Yeah, that's what you meant with the
Yeah. So it's like, and then there is like originally Facebook called GraphQL supergraph.
I didn't know that. I've never
you didn't know that?
No.
The first like I used to open my what is GraphQL talks with that, and the first commit, the first version of GraphQL was called supergraph at Facebook, for lack of a better name. That was what.
Well, let's keep thinking, but I do think like if we're like describing these phases, for instance, like the terms need to be descriptive. Like we don't want to be, because we want to avoid certain terms, we don't want to make things unclear. And I think subgraph validation, for instance, to most people makes it clear what that is, and maybe there's another term that we can use there.
That's it. Yeah, I'm not against finding a better term, right? That's like as everything in the spec. Let's come up with some better thing. Like I think we had also discussions around lookup. At the end, we landed a very good term.
Yeah.
So let's discuss. Let's maybe do a couple of suggestions, everyone, again, and then we gonna land on something. what is important is that if you read this specification, you also have like a relation into the core spec. That's why it has to be something schema, because we are composing schemas here.
Well, yeah, but that, I mean, we do use the term subgraph schema and supergraph schema. That's what, like.
Yeah, but there are also very different terms. Like, for instance, public API. Like there is a missing consistency there. Like suddenly we are not talking about graphs or schema anymore. Then it's an API suddenly, and like now at the moment we have very, very clear distinction. Everything is a schema. We have a client-facing composite schema. That is basically what the user is facing. Then we have the executable composite schema is what is with directives. But let's find terms for it. I don't mind. But like I'm just saying, there's a lot of like what I dislike about supergraph. It has become a marketing term. And that makes it less accurate because everybody tells you this is a supergraph, but it's a completely different thing underneath.
Yeah.
And it's a bit...
The subgraph connector, that's Hasura thing.
Yeah, it's a
specific.
pity.
Yeah.
It's a pity that they do marketing on that. But anyway.
Who is this? Is this a bot that sort of correcting? Like, because I saw that same person on other.
No, he's from our team.
Okay.
He's a Chile, but he's a native speaker, so we
I
always.
I didn't recognize him, so it's just like there was like a person showing up and just making grammatical corrections. So it's because he did that on the other PR as well.
Yeah, he was the one which implemented my first selection path draft. Because we said that we want to separate the specification writing and the implementation, because then two people think individually about it, and that's the reason why it's really active there.
Yeah, and since we are Europeans and he is a native English speaker, he's from South Africa. He's also fixing mistakes.
Yeah, that makes sense. Well, maybe we'll get to meet him someday.
Yes. He's not so keen on online meetings. He's a bit more shy, but we tried to bring him to a GraphQL Conf, but yeah, maybe next time.
Yeah.
But so the general structure is, let's get that at least a bit more refined. So we have the validation, right? And that's the isolated validation of one schema. Is that correct?
Yeah.
Okay. And then we have the compose step, which we rather call merge. And that will basically not blindly, but will basically merge things together. So make it one schema.
Yeah.
And then we have the satisfiability rule.
Well, there's something before that, because there are additional validation rules that apply to the composed schema. In between
the merge step.
Yeah, in between the merge and satisfiability. Yeah. So for instance, like the first validation step, the subgraph validation, doesn't validate that the fields in a require are actually defined in other subgraphs in the supergraph. Yeah. And you can only do that after merging, because then you have the full context. But you want to do it before satisfiability, because you need that information to like compute satisfiability.
Yes, I think we originally also went this direction and said like the merge step could still fail, could still produce an error, because you kind of like now you have all schemas in context, and when you are merging a type, you kind of validate it. Or
yeah, we could also define it in that way, like make it part of the the middle stage of the merge or compose stage. Yeah.
I think that it would be easier if I mean, some stuff we automatically validate. If we cannot merge, then we have to fail, right?
But hopefully that would have been detected by the subgraph validation.
Well,
or no, you're right. It
Requirements
wouldn't.
you cannot
yeah,
requirements
but
for instance.
requirements, I would say that's even a later step. I mean more when you have on one subgraph it's a string property, on the other subgraph it's an int property.
You're right. Yeah.
You find this in the merge, and then you have a composition error in the merge. But the merge stuff is more difficult to have a complete validation output, because you could produce stuff which basically just stops the merging from working, and then you run into the issue that's much more difficult to collect all the errors. So, to get a good output, it's nothing more annoying when you have to fix an error just to see the next error in the.
And I see, Pascal, we actually defined the validation rules in isolation, because this is the field type validation. It's up here. So the validation we did here is not only the isolated validation steps, it's also the integrated.
I mean, also some errors makes no sense if some other validation rule was executed and failed, right? There's some not dependency, but and not dependency, but I mean some rules just don't make sense.
Yeah.
Yeah, could it be that there's even 3 validation steps? Could it be that there is just a subgraph validation or a source schema validation, however we call it? Then we have a validation step that has knowledge about all the source schemas, so we can do the field types mergeable stuff. We can run it, and it has basically the input is a list of schemas, and the output would be it's highly likable mergeable, and then we can still have the runtime merge exceptions that are failures, because then we can always compute the full output of issues that you have, right?
I think you're right with the 3 stages. I think the distinction I would make is, there's the subgraph validation in isolation. Then there are validation errors that sort of keep us from constructing a supergraph in the first place, like field types not matching, the example you mentioned. And then once you have a supergraph schema, there are additional validation rules that sort of you want to check.
So merge
how do we call it? Is this a pre-merge validation, or? Sorry, Derek.
I would just say merge validation. So if you were talking about validations that are right, so just source schema validation, merge validations, then you have the executable or supergraph schema validations, right? And then there was the last one with the satisfiability validations, right?
Yeah. But if we're talking, we first do this, then we do merge validation, then we do merge, and in merge can also be errors, right?
No. I think merge and merge validation. I would say that a merge can fail. And it's up to the implementation, sort of whether you perform checks beforehand or whether you do the merge and sort of encounter errors as you perform them.
I think
how do we describe it? Sorry, Pascal, go ahead.
Yeah, I think what we have to define is how we want to
describe
it, because it could be that it's much easier because we've already written the merge rule stuff and so on for the initial fusion specification, and it's much easier if you can just assume that the things go together. So even if we would have one merge step which has 2 chapters, the validation for the merge with all the validation rules which have the context of all the schemas, And then we just define the merge rules, because the merge rules, again, are algorithms that we write in text, right? It's get this in on type, get this in on type, see if they fit. I mean, not see if they fit together, but make them fit together with take this part from here, this part from there, whatever. So even if the implementation does it differently, which I wouldn't care, I think it's probably easier for us to specify if we can just assume that the things go together. And I would say everything that doesn't go together is just an unexpected exception. After the validation, it should match. If it doesn't match, then there is a mistake in the validation rule.
I agree with, I think I agree with what you're saying. I don't necessarily agree with what's on the screen. I would say we have a source schema validation, then we have a merge, which can also fail with like validation errors. That's what Pascal was just describing. Then we have a composed schema validation, and then we have satisfiability.
But there are two things. Like if the merge algorithms can fail, there's more algorithm text for the actual merge. We like this is two things we can do. We can do it like this, so we handle all validation rules in one place, or we move that down here and have like a validation within merge and then the actual merge algorithms.
Yeah, I think
or we can have just the merge and leave that completely out. But then the algorithms for merge are more complex to read and understand.
Also,
how does the GraphQL spec do that? I think it does have things like do field arguments match or something as an algorithm, right?
It depends. Like it has the general validation is a separate, like it's also in the execution of the GraphQL. First validate and then you execute, so you already can assume that everything is right, because we have the validation chapter. Sorry, let me add on the slide here. Yeah, so this is the general validation, like for instance, like that you have that you cannot have duplicate names, for instance, that the arguments about merging and stuff like that, this is done before the execution. It's also implemented like that, right? You come in and it's validated. And this means all these checks we don't have in the execution algorithms.
Yeah, I would highly prefer that, because that makes the merge rules really easy to follow. It
doesn't have to be implemented like that, right? You can also do it different.
Yeah, it just makes it much easier to just assume that things fit together, and otherwise you just have an error.
Yeah.
And
but we also have, like, there are also execution errors, right? Like if we, for instance, get here, resolve something in here, it also has these quick errors. For instance, like the validation will validate already that an operation cannot be duplicate, but we also have here, like, if document contains exactly one operation, return operation, otherwise raise an error.
So it is sort of duplicating the validation rule as part of the algorithm here.
Yeah, but much more simple now, right? There's no example for it. There's just, because we already validated that. But you have to assume, like in the GraphQL execution rules, we assume that you could also disable a rule because for whatever reason. So this is the, like, you anyway have to have like a fallback here.
Yeah, I don't think that we need it in merge, because it would be a missing validation rule, and I think we have pretty strict validation rules which have to be followed in the specification. It's not like that you can disable one, or can you?
Yeah.
You have this flexibility that you can disable one and then just hope that it goes together.
I don't think that's true of the core
Mm.
rules. Yeah.
No.
Yeah, so then I think we could just assume that it goes together with the node.
I think even for warnings, if you upgrade them to errors, this is an implementation detail for the implementer that would not be described in the spec. We just described this as warning, this is an error. And if you want to have warnings as errors, implementation detail.
One thing which is really good if we have separate validation steps and don't mess with validation in the merge is that we can define error codes. Like can you open the composite schema specification quickly?
Yes.
Left tab.
This is here.
You see we have an error code, for example, for field types mergeable. And this is really valuable if cross implementation you somehow get the same error codes. So for example, if you have a composition running with Rover, I believe, or with one of the fusion tools, you basically know if I get F002, you know what's wrong. So even the documentation can help you from different places.
Yeah.
If we specify the error codes as validation errors.
I would prefer like descriptive error codes, I think, and like we have some examples in our documentation, but I agree that it's useful.
Yeah, I mean, you mean descriptive, you mean, for example, capital case with underscores or something like this, that field types could not be merged, something like this.
Something like that, yeah.
Yeah, I'm not just talking about the cross implementation identifier that you at least find documentation about it from somewhere.
We probably should also, that is something I would at least recommend, have an appendix with also the suggested message text, because that will lead to less like easier implementation for people, and less like with GraphQL servers, we have, for instance, tools that predict implementations from errors, and if we can come up with, like here, this is the message text that we also suggest you take, you don't have to, then this will make a very good error experience, like having the text and the error code.
Yeah. Okay. Can you open the VS Code again quickly? Just the main thing is just that we get the structure right. So we say that we have actually just one, the source scheme validation. Then we have the merge validation. Then we do the merge. And the question is, do we need, after the merge, do we need another validation except for the satisfiability? I don't think so, right? Because we should have already validated that the schemas go together correctly.
I mean, the satisfiability is the validation, no?
Yeah, but there are other rules as well. I'm not sure. Like, we can definitely categorize everything as a merge validation, like all the composition, like all the supergraph level validations. We make a distinction between validations that sort of prevent the supergraph schema from being constructed in the first place. And that's like, if field types don't match, like there's no way for us to even generate a supergraph schema, because in the supergraph schema, the field needs to have like one type. But for things like require, that is an additional level of validation, because you can still construct a supergraph schema, but perhaps the fields that you're mapping to doesn't exist, or doesn't have the right type. But maybe that's not a useful distinction here. Like we can definitely say that that's all part of merging.
I think what would make it easier is that we know exactly where stuff goes. If you only need the context of one schema, it's source schema validation. If you need the context of all schemas or the composed schema, then it's merge rule validation. And then we don't have these two places where stuff can go, right?
So
Because
it's,
otherwise it could be
Yeah.
either or, right?
but it's a bit like this, right? In the source schema validation, and we pass in a single source schema. In the source schema merge validation, we pass in all. In merge, we pass in all the source schemas and get out the composite schema, and satisfiability is we pass in the composite schema, but there's no change to it anymore. Because that is just, again, validation.
Yeah, I think if we would have to structure the headings for the docs, I would say we do source validation, source schema validation, merge with two sub headings,
Okay.
and satisfiability. I think then it's quite.
It's
so
not
that-
only satisfiability, it's merge. How would you would also have to
the actual
have
merge.
yeah.
One example of like a validation rule that could run before, like in between the merge and satisfiability, is like the
You can-
requirement for the key fields. So for example, if an interface has a key field, that it needs to be aware of the rest of the objects. So, you know, then you need to know pretty much the whole history of the subgraphs.
What
So
one
it's like,
suggest-
it depends what you mean by merge. Like, is it like let's call it like super state versus the new subgraph, or it's like the new subgraph versus, you know, that is merged with the rest. So it's just that the state there is different, right? So if you like merge a field type, then you pretty much just need the previous that is like, you know, in the super graph, or like will be potentially, right? But if you want to have like key fields and like, you know, dependency, like the implement like a union intersection and so on, it's like, you know, you need to know a bit more than just the state of the supergraph.
Yeah, I would say the input in the merge validation are all the source schemas. So even for requirements, you would have access to all possible types from all possible source schemas. The only thing which is really an issue is that you would have to merge them on the fly, which is a bit annoying.
Well, but now you're talking about implementation again, and I think
No,
that
I mean in the specification text, you would have to say you would have to define a function in the algorithm that says that we merge. You know, you have this problem. You have what was first, the chicken or the egg? Because to verify require, you have to merge, but to merge, you have to run the merge validation.
I mean, that's why we have that as a separate stage. So certain merge validation rules are sort of more isolated, like the field types have to match, but others really need the whole supergraph context.
Yeah, I see. That makes sense. Then we actually have another validation. Then it makes sense to have. Yeah, because you have the problem that sometimes you need the merged context to do the validation. For require is the best example for it. And the only way to do this, if you think about is this require valid? If you write the validation rule for this and you only have the source schemas as input, then you would have to get, if you have a product requirement, you would have to get all product types and merge them together to see if the require works. But to do that, you have to merge them. And to merge them, you have to run the validations.
Yeah, so the question is whether you count those validations under satisfiability and just that is a big umbrella that runs all those validations, or you call those out explicitly that you're validating the composed supergraph, the schema, and then you do the satisfiability as a separate step.
I think satisfiability is complex enough to require its own section, I think.
Probably it would be better to call it out separately. Yeah, I agree, but it's one way to look at it, right? That potentially could be lumped together, but
also the satisfiability is like the core pretty much of it all. So
I mean, in the end, I think that's sort of where,
Satisfiable,
yeah, for a lot of the real checks happen, but there are definitely things that need to be checked beforehand, like the requires or like the keys match or
requires is a fundamental type check, but it doesn't mean that it's satisfiable. Still, also the requires, and so the satisfiability is more about query planning. That the query planning will work out.
Yeah.
Whereas the other validation parts,
I'm not even sure if satisfiability is specifiable with algorithms or if it should just, I mean, in spec text. In the end, it is one, but could be an implementation detail. It could also just be description of how, how it's performed, because it really depends on the implementation, how you want to do it, right?
Yeah.
But we should have rough algorithms for that.
But probably a not very realistic algorithm that won't work with large schemas if you implement it as such.
Yeah, I mean also the GraphQL spec has not the most efficient algorithms, and we want an easy way in, and then you anyway optimize it for your platform.
I would say satisfiability is a root. I wouldn't put it under merge. I would say that's its own thing.
Oh yeah, no, definitely, yeah.
Yeah, because it's too complex. I would keep that separately because it's a very complex thing. So yeah.
And then the question is, do we have? Yeah, that's a good heading. That's perfect. That's going to be going to specification. And then the question is, we probably have. Let's call it the. Just that we have a name for it, the source schemas validation, and then we have what do we call the composed schema?
Yeah, but what about like pre-merge validation and post-merge validations or whatever?
That might
also call it like
also work.
I don't mind.
This is the pre-merge.
Yeah. And then we have the post-merge. I think that's a reasonable structure.
We have to find better headings, but it's important to have a structure here.
Because what we could do now with that we have these rough structure.
Should we move this into the source schema chapter, like into this chapter?
I would keep a composition. That's perfect, because then you see what happens in composition.
Okay.
Because that's exactly what you would do, right? You wouldn't when you these are the steps that run. I like this idea. But what we can do with these headings now, we could each take one of the headings and specify it out. No, I'm kidding. We could take each one a heading, and then we could just think until the meeting in a week what more or less goes in there, just a rough outline. So that we can.
It's not about the specification text, but a bit like the rough.
What are the rules that go
if the structure makes sense?
Yeah.
Because I'm pretty sure that.
Or if we need any substructures, things like that we get a rough idea of the structure, and then we're gonna anyway go in detail into each.
I would say we have an outline like for the merge, because we already have a lot for merge, about the different merge rules, just in general, what whoever takes this topic comes up with, because I'm pretty sure that in the discussion what's pre and post merge, we will probably switch a few rules between the two, because if you think about require, it goes into post-merge, but there are other rules which might seem like they go into pre-merge, but are actually post-merge rules and stuff like this.
I mean, I think we have a pretty clear rule, right? Like if you require the composed schema, then it's a post-merge validation.
Yeah, true. The question is, do you require it or not?
Yeah.
I mean, technically, you could also write require without in the pre. you iterate over the schemas and validate that. It's just
Well, yeah,
inefficient.
but that in every validation rule, you're basically performing a merge.
Yeah. It's inefficient. Yeah, that's what I say. There's
Yeah.
no clear distinction. It's more about, is it efficiently to do here? So also something you have to think about. Like,
Yeah, I think the it's easier to just define it where it fits the best, because it's in the end it's specification.
Yeah.
Maybe
there is an important distinction, I think, and I think that's how we've defined it so far. Like the pre-merge validations, those are validation rules that may require context beyond a single source schema. So you may require context from other source schemas, like knowing what other schemas have defined as a field type for the same field. But you cannot refer to the composed state. Like you cannot refer to the composed schema.
Yeah. It makes sense. The pre-merge validation, the big difference is pre-merge validation iterates over types, so to say. And the post-merge validation has only one type because it's merged.
Yeah, so let's maybe we have a couple of rules, and I can also we can put them maybe in the chat later, like a bit outline, like just title headers of the validation rules we have, and then we can sort through them. And also everybody can say if there are rules missing that you guys have or that Kamil has, that we come up just with a list of the validation rules and where they belong.
Can you post them as
Yeah,
individual messages into Slack? Because then we can start a thread for each one and discuss.
Yeah, we'll go over the rules that we have, and but I will just kind of post a bit a header and description. Okay, this rule basically validates that without any algorithms, just that we get an idea. These are the rules, and then we can sort them through, and then we can later start specifying them.
All right.
Sounds good?
Sounds
okay.
Cool.
And see you all next week.
Cool meeting.
Yeah.
And have a good week.
Yeah, you too. Thanks.
Bye.
All right.
Bye.